So my name is Ann Plant. I'm with the National Institute of Standards and Technology. And together with Krish Roy, we are co-chairing this workshop on applying systems thinking to regenerative medicine. I'd like to thank, and we will thank them more formally, the rest of the committee that has worked with us to put this workshop together. The reason, the real motivation for this workshop is that critical quality attributes, what do you measure about a product that really characterizes it and tells you how well it's going to work in a patient? This is a very challenging issue. And it's recognized to be challenging by regulators as well as by practitioners. And the reality is that we know that you can't measure one thing is not going to be enough, but there are many things that could be measured, and to figure out what has to be measured that will actually be predictive of the efficacy and safety of a product that's as complex as a cell-based therapy. This is a real challenge. And it continues to be a challenge because even for therapies that are beneficial and successful, there's still not enough correlation between what is measured and what the clinical outcome is. And so it's very important that we understand, have a better understanding, and develop the tools that are required to really understand how these therapies work and what their characteristics are that make them work. And one of the other motivations here is that we're entering a world where there is a lot of data at our disposal, mostly through omics type technologies, but there's still challenges of how to parse these data, how to analyze them, and how to put them in a theoretical framework that tells us the context in which we should evaluate the measurements that we can make in order to provide some predictive capability. Now, in addition to all of this, which gives us a handle on mechanisms of action, the ecosystem of the regenerative medicine space is huge. There are lots of issues that come up. There's an ecosystem that's involved in how regenerative medicine products get developed. And so this ecosystem is, provides us systems within systems, if you will. And so it becomes very complicated. And in addition to that, even things that we might not necessarily consider to be part of systems biology for sure, are things that involve supply chain. These are all very complex systems as well. And so we're hoping to touch on all of these issues over the course of the next couple of days. I'm going to, and what we're hoping to do here is to look at how can we deal with large-scale data that might come from many different sources and provide different kinds of information, and understand how to analyze that data and how to put that data into a context that provides us with a good handle on what we should be measuring, that gives us information about critical quality attributes and gives us information about critical processing parameters. And because we will have that information, it's then easier to know how to make a decision. And so this is the goal, the overall goal of what we're hoping to delve into in the next couple of days. I want to turn it over to Krish Roy now from Georgia Tech, my co organizer of this workshop. Thank you.